So in this problem, we want to find the area of the shaded region, and none of the pieces are going to be incredibly different, but it is going to be quite a few pieces to finish this problem. So first of all, if you're looking for the area, we know we're going to want to take an integral. But the problem is, remember, we have to worry about if we have stuff below the line or stuff above the line. And so we're going to have to kind of do it in two pieces. We're going to have to go from here to here, and then from here to here. Okay. So in the very first piece, this piece right here, we would want to take the integral. Okay. And now, you always kind of consider that like y equals 0 is the top or bottom function, so that's kind of our function, and we're finding the area in between these two. So the top function here would be y equals 0, so it's going to be 0 minus this 8x square root of 16 minus x squared dx. And then let's take the integral for, find the area for this piece. And so on this piece, it would be the integral. But now the top function is your actual function. We're interested in the 8x square root of 16 minus x squared. And then you would minus the bottom function, which is 0, and that just doesn't do anything. But we do need to know the limits that we're integrating. And to do that, you can't just look at the graph, because it's not in enough detail for you to know the numbers. Instead, we're going to have to set our function equal to 0 to figure out where it crosses the x-axis. So we need to find the x-intercepts for our limits. So you set your function equal to 0. So 8x square roots of 16 minus x squared equals 0. And take each piece and set it equal to 0. And solve for x. So over here, x is just going to equal 0. And then over here, let's see, we can square both sides. So we get 16 minus x squared equals 0. X squared equals 16. X equals plus or minus 4. So coming back over here, this point is negative 4, 0, and 4. Those are our limits. Okay, so let's see, our first one, where the function was underneath, that went from negative 4 to 0. And over here, we're going from 0 to 4. And it's not necessary, but I'm going to write here, these are x equals, just to kind of remind myself later. And just in case I do use substitution, but I might not. Let's see what we actually have to do. So we finally have set up, we're going to integrate from negative 4 to 0 of a negative 8x square root of 16 minus x squared dx, plus the integral from 0 to 4 of 8x square root of 16 minus x squared dx. Now, do you notice this negative here? Let's just go ahead and pull that out to the outside. You can always pull a negative out. You can pull any number out. And now, these two are going to be the same. And that will just be nice, because now I only have to integrate it once, and then I can just plug in my limits twice, but I don't actually need to integrate it multiple times. Okay, so let's kind of do inside. Let's forget about limits and the two different things, and let's just integrate. Try and figure out, how do you integrate 8x times square root of 16 minus x squared dx? So when I look at this, I always try to use substitution first. That's just easier for me. So usually whatever's inside the square root would be your u. So let's try it and see if it works. So u equals 16 minus x squared. So then the derivative of u with respect to x would be negative 2x. And so then the du would be negative 2x dx. So let's come back over here. We don't have a 2x, we have an 8x. Okay, so let's see, if I wanted this to be the integral of maybe something times negative 2x square root of 16 minus x squared dx. Because this part here and here, that would be my du, and this would be u. So how could I make this look like this? What would I need to put here to make that work? I currently have 8x. I need a negative 2x. What if I put this as a 4? What if I put a negative 4? Because then I'd have negative 4 times negative 2x. That does give me 8x. So that negative 4 is going to need to come out of my integral. So if I pull the negative 4 out, then I'm left with negative 2x square root of 16 minus x squared dx. Okay, now if you prefer, you might have come up here and said, oh, I have 8x, but I really want a negative 2. So you could have times this part by negative 1/4, and you would have times the outside by negative 4 to make sure you balance, because negative 4 times negative 1/4, that's just like a magical 1. And either way, your negative 4 comes to the outside here. So this is going to equal negative 4 times the integral. Now take this negative 2 in dx, and that's your du. And this square root of 60 minus x squared is now the square root of u. So this is negative 4 times the integral of u. Let's replace that to the 1/2 du. Now we're finally ready to integrate. This is going to be negative 4 integral. Sorry, not integral. We're going to actually integrate now. We'll take our u, raise the power by 1. So 1/2 plus 1 is 3/2, and divide by your new power. Let's see, so negative 4 divided by 3/2 is negative 8/3 u. And there's two ways you can do it. You can find your new u limits, but sometimes it's easier for me. Let's just go ahead and plug our x's back in. So this is going to be negative 8/3, and instead of a u, let's put our x's. Oh, sorry, u to the 3/2, somehow I dropped that power. So we'll have 16 minus x squared. So 16 minus x squared to the power of 3/2. So now that we've done all that, we've figured out what the actual integral is. Let's go back up to what we were actually trying to find. We were trying to find the area, which was equal to the integral from negative 4 to 0, and we had a negative on the outside here of, here, let's just copy this and pull it down. Yeah. Okay, so this is the area that we wanted to find, and remember, way up here, this thing that we just found here, so this piece is the integral of this, and it's also the integral of this, since those were the same thing. So what we're going to have here is we're going to have a negative, and let's go ahead and plug in our limits for this first one. Our limits are from negative 4 to 0, so you always plug in the top first. So it's this negative 8/3, 16 minus x squared to the power of 3/2. So negative 8/3, 16 minus, plugging your top limit with 0 first, squared to the power of 3/2. Minus, now you plug in your negative 4. So negative 8/3, 16 minus negative 4 squared to the power of 3/2. Plus, now we're going to do our next one. So it's the exact same thing. So negative 8/3, 16 minus x squared, 3/2. So negative 8/3, 16 minus your x, which is 4, squared to the 3/2, minus, and do your negative 8/3, 16 minus, let's see, our bottom limit is 0, squared to the 3/2. I know this takes a long time to plug in your calculator, so we're going to have a negative, and our first piece of the integral gave me negative 5/12 over 3. Plus, and if I do my next half, I get positive 5/12 over 3. So we add that negative, negative makes it a positive, so together we should get 1024 over 3. So that's our final area. The biggest thing coming up is if you didn't do the 0 minus right here, this piece of your area would be negative, and that's why you have to have like a negative out front to make it so this is a positive area, just because when you just do the integral, it's going to give you a negative because it's below the x-axis.